Have you ever wondered why some people can skip a meal without feeling tired, while others become hungry, sluggish, and irritable after just a few hours? The answer isn't simply about willpower. It's about whether your body remembers how to use the fuel it has been storing for years. Right now, your body is carrying an emergency energy reserve that was designed to keep you alive during times of food scarcity. Yet for millions of people, that reserve is almost never used. Not because it isn't there, but because modern eating habits rarely give the body permission to access it. Today, we're going to follow your body hour by hour as it moves through 6 distinct stages of fasting. You'll discover what changes inside your cells, when fat burning actually begins, why hunger doesn't behave the way most people think, and how giving your digestive system a simple break may trigger processes that have nothing to do with weight loss. Some of these changes happen while you're sleeping. Others don't appear until you've gone an entire day without food. And the final stage reveals why scientists became so interested in prolonged fasting in the first place. But before we begin, if you enjoy evidence-based health videos that explain the science behind your body in simple language, make sure to subscribe and turn on notifications. Every week, we explore practical health topics that can help you understand not only what your body does, but why it does it. Now let's start where every fast really begins. Most people think fasting starts the moment they finish dinner. It doesn't. Imagine your body as a house connected to 2 completely different power systems. The first is the main electrical grid. That's the food you've recently eaten. As long as electricity keeps flowing from that source, your house has no reason to switch to its backup generator. Now, picture a massive generator sitting quietly in the basement. That's your stored body fat. It's capable of providing energy for days, sometimes even weeks, depending on your body composition. But there's one problem. The generator remains locked until your body decides it's truly needed. The key controlling that lock is a hormone called insulin. Every time you eat, especially meals rich in refined carbohydrates or sugar, insulin rises. Its job is incredibly important. It helps move nutrients into your cells while telling your body to keep using incoming food as its primary fuel. But while insulin is elevated, something else happens. Your fat stores stay largely closed. It's as if someone places a do not open sign on your emergency generator. This creates one of the biggest misunderstandings about fasting. Suppose you finish dinner at 8 o'clock in the evening and wake up at 7 the next morning. You might think you've completed an 11-hour fast. In reality, your body may have spent the first 3 or 4 hours simply processing that large dinner. Only after insulin falls back toward baseline does your body begin transitioning into a true fasting state. That means an 11-hour overnight fast may actually provide only 7 or 8 hours of genuine fasting. A simple habit can change that dramatically. Finishing dinner 2 or 3 hours before bedtime gives your digestive system enough time to process the meal before you sleep. Instead of spending most of the night digesting food, your body begins moving toward repair mode while you're resting. Around the 12-hour mark, something subtle but incredibly important happens. Insulin continues dropping. For the first time since your last meal, your body receives permission to explore another source of energy. The doors protecting your fat reserves begin to unlock. This doesn't mean you're suddenly burning massive amounts of fat. Instead, your metabolism starts becoming flexible again. Rather than relying entirely on recently eaten calories, it slowly begins reaching into stored energy reserves whenever needed. Think of it like owning a hybrid vehicle. Instead of running exclusively on gasoline, it finally learns when to switch to battery power. That flexibility is something many modern lifestyles slowly erase through constant snacking and frequent meals. But the story becomes even more interesting. Because once your body realizes that no new food is arriving, it doesn't simply search for fuel. It starts cleaning house. Between 14 and 16 hours, your cells recognize that nutrients have become temporarily scarce. Rather than wasting resources, they become more efficient. Scientists call one of these processes autophagy. Although the name sounds complicated, the concept is surprisingly simple. Imagine every room inside your home slowly filling with broken furniture, damaged appliances, old newspapers, and boxes you never throw away. For a while, life continues normally, but eventually, the clutter begins getting in the way. Your cells face a similar problem. Every day, they accumulate worn-out proteins, damaged components, and tiny pieces of biological debris created through normal living. Usually, those materials are recycled slowly. But during fasting, the cleanup process becomes far more active. Instead of allowing damaged material to accumulate indefinitely, your cells begin breaking it apart, recycling useful pieces, and removing what no longer serves a purpose. It's less like taking out the trash and more like renovating an entire building from the inside. This is one reason researchers have become increasingly interested in fasting and healthy aging. Your body isn't simply conserving energy. It's investing that energy more wisely. Many people expect these first 16 hours to be the hardest. Surprisingly, that's often not the case, because another fascinating shift is already beginning. At first, hunger arrives exactly when you'd expect. Breakfast time comes. Your stomach growls. You feel convinced you need food immediately. But here's what surprises most people. Hunger doesn't increase forever. Instead, it arrives in waves. Each wave rises, peaks, and then fades away. The longer you observe those waves instead of reacting to them instantly, the more you realize they aren't constant emergencies. They're signals shaped by habit, routine, and hormones. And once your body starts preparing its next fuel source, those signals begin changing in ways that many people never expect. Because beyond the 16-hour mark, your metabolism is getting ready to perform one of the most remarkable fuel switches in human biology. And that's where fasting begins to feel completely different. By the time you move beyond the 16-hour mark, your body reaches a decision point. It can continue waiting for another meal, or it can finally activate the backup system it was designed to use all along. Around 18 to 20 hours into a fast, your liver has burned through much of its readily available glycogen, the stored form of glucose that acts as your body's short-term fuel reserve. Instead of sending your brain into panic mode, your metabolism makes a remarkable adjustment. It begins converting stored body fat into molecules called ketones. Think of ketones as premium backup fuel. Unlike glucose, which depends heavily on frequent meals, ketones are created from the energy already stored inside your body. Once they begin circulating through your bloodstream, something unexpected often happens. Your hunger starts becoming quieter. This sounds completely backwards. Most people assume the longer you go without eating, the hungrier you'll become. But biology tells a different story. The hormone responsible for much of your hunger, ghrelin, doesn't continuously rise throughout the day. Instead, it follows a schedule based largely on your eating habits. If you normally eat lunch at noon, ghrelin rises around noon. If no food arrives, that wave eventually falls again. The same thing happens later in the evening. Hunger behaves more like ocean waves than a steadily rising flood. Once your brain begins receiving ketones as fuel, many people notice another surprising benefit: mental clarity. Instead of the familiar afternoon crash that follows large meals or sugary snacks, concentration often becomes steadier. Many people describe feeling calmer, more alert, and surprisingly productive. This doesn't mean fasting makes everyone instantly more focused. Sleep, hydration, stress, medications, and overall health still play major roles. But it helps explain why many people report that fasting becomes easier after the first several hours rather than harder. Your body has successfully switched fuel systems, and it's only getting started. Now another transformation begins. Around 24 hours without food, your body starts prioritizing repair over growth. Earlier, we talked about your cells cleaning away damaged material. Now imagine that cleanup crew receiving stronger equipment. Instead of simply removing small amounts of debris, your body becomes increasingly selective, identifying older, damaged, or dysfunctional cellular components that no longer contribute efficiently. At the same time, your digestive system finally gets something it almost never receives: a complete break. Every meal requires your stomach pancreas, liver, intestines, hormones, digestive enzymes, and gut lining to work together. They perform this job every single day. Giving these systems temporary rest allows maintenance processes to catch up. Researchers have also investigated how fasting influences inflammatory markers throughout the body. While fasting is not a cure for chronic inflammatory diseases, some studies suggest that carefully managed fasting periods may reduce certain markers associated with chronic low-grade inflammation. This matters because persistent inflammation has been linked with many age-related conditions, including cardiovascular disease, insulin resistance, and metabolic disorders. In other words, fasting isn't simply about eating less. It's about giving your body's maintenance department enough uninterrupted time to do its work. But perhaps the biggest misconception about fasting appears next. Many people worry that if they fast for 2 days, their muscles will immediately begin disappearing. Fortunately, your body is far more intelligent than that. Around 48 hours into a prolonged fast, levels of human growth hormone, or HGH, can increase significantly. This often surprises people because growth hormone is commonly associated with building muscle. During fasting, however, its primary role is different. Instead of building new muscle tissue, it helps preserve the muscle you already have. Think of it as placing valuable belongings into a secure vault before renovating a house. Your metabolism understands that muscle is expensive tissue. It requires energy to build and maintain. If food temporarily disappears, sacrificing muscle immediately would make survival much more difficult. Strong muscles help you move, hunt, gather food, and protect yourself. From an evolutionary perspective, preserving muscle while using stored fat makes far more sense. This is exactly why prolonged fasting shifts more heavily toward burning fat whenever sufficient body fat is available. That doesn't mean unlimited fasting is always safe. People who are underweight, pregnant, living with diabetes, taking glucose-lowering medications, or managing chronic medical conditions should never attempt extended fasts without medical supervision. Safety always comes first. Another important detail is how you end a prolonged fast. After 48 hours, your digestive system has been relatively quiet. Throwing an enormous pizza, sugary dessert, or heavily processed meal into that system all at once can leave you feeling miserable. Instead, breaking the fast gradually give your body time to wake digestion back up. Foods rich in protein, healthy fats, and easily digestible nutrients are often far better choices than overwhelming your stomach with a large processed meal. Then comes the stage that captured the attention of researchers around the world. Around 72 hours into an extended fast, fascinating changes involving the immune system have been observed in certain clinical studies. Some research suggests that prolonged fasting may encourage the removal of older immune cells while stimulating processes involved in generating new ones after refeeding. Think about that for a moment. Your immune system isn't simply resting. It's potentially undergoing a period of renewal before rebuilding itself once nutrition returns. This research generated enormous excitement because it suggested that fasting may influence regeneration in ways scientists had only begun to understand. However, it's important to keep these findings in perspective. Most of these studies were performed under carefully controlled conditions, and prolonged fasting is not appropriate for everyone. More research is still needed to fully understand who benefits most, how often such fasts should be performed, and what the long-term effects may be. Which brings us to perhaps the biggest lesson of all. The purpose of fasting is not to prove how long you can survive without food. It's not a competition. The real goal is developing metabolic flexibility. Imagine owning a car capable of running on 2 different fuel systems. If one temporarily becomes unavailable, the vehicle simply switches to the other without hesitation. Your body was designed the same way. It should comfortably burn the food you eat. It should also comfortably burn the energy you've already stored. Unfortunately, years of constant snacking, sugary drinks, late-night meals, and highly processed foods can make that transition increasingly difficult. Instead of smoothly switching fuels, your body begins demanding another meal every few hours. Energy crashes become normal. Cravings become stronger. Fat burning becomes less efficient. Consistent fasting schedules help retrain that flexibility. For some people, a daily 16-hour fasting window fits naturally into life. Others may prefer occasional 24-hour fasts. The exact method matters less than consistency, quality nutrition, proper hydration, regular movement, and adequate sleep. Remember, fasting is only one tool. It works best alongside healthy eating, resistance training, stress management, and sustainable habits that you can maintain for years. So let's bring everything together. At around 12 hours, insulin falls and your body begins unlocking stored fat. By 16 hours, cellular cleanup becomes more active. Around 20 hours, ketones begin fueling your brain and hunger often becomes easier to manage. At 24 hours, deeper repair processes and digestive rest become increasingly important. Near 48 hours, growth hormone helps protect lean tissue while fat continues supplying energy. And around 72 hours, prolonged fasting may influence important immune system renewal processes under the right conditions. You don't need to reach every stage to experience meaningful benefits. Sometimes the greatest transformation doesn't come from fasting longer. It comes from fasting smarter. Give your body consistent opportunities to rest, repair, and adapt. Because hidden beneath every meal you skip isn't just an empty stomach. It's a remarkable biological system waiting for the chance to do exactly what it evolved to do.